learning outcome. After studying this module, you shall be able to know that about pesticides and their classifications, learn about the mode of action of pesticides, learn about the toxicokinetics, introduction to pesticides. Chemicals have been used to exterminate or control pests for centuries and thus known as agricultural chemicals. The term agricultural chemicals has largely been replaced by the term pesticides, defined as economic poisons regulated by national and municipal laws that are used to control, eradicate or repel pests. From the past history, it is well established that the Chinese were familiar with the use of arsenic to control insects, while the early Romans used common salt to control weeds and sulfur to control insects. In the 18th century, a compound named pyrethrin having insecticidal property was found present in the flowers of the chrysanthemum, Pyrethrum cineifolium. The Chinese and South American citizens learned to use the roof of various dairies plant species as a fish poison in the period in between. Rotenone was discovered in 1895 and used for insect regulator during this decade. Paris green, a combination copper and arsenic salt, was discovered, so as the Bordeaux mixture, a combination of lime and copper sulfate. During 1940s, chlorinated hydrocarbons insecticide such as DDT, the phenoxy acid herbicides such as 2,4-D, natural compounds like red squill extracted from the bulbs of red squill or Arzinia celia martima, effective in controlling rodents, were introduced. Atrazine, a triazine herbicides introduced in the late 1950s, ruled the world herbicides market for years. Synthetic pyrethroids or pyrethroids insecticides, example resmethrin, became an extensively used insecticide because of their low noxiousness, increased preservance in respect or to the pyrethrum, and less used. Pesticides are rare amongst environmental pollutants in that they are used intentionally for the purpose of assassination some kind of life. Ideally, pesticides should be highly selective, abolishing objective organism through leaving non-target organism unhurt. In reality, most pesticides are not so selective. Depending on what a substance is formed to do, pesticides have been subclassified into several of categories. The major classes of pesticide in use today are fumigants, fungicides, herbicides, and insecticides. Forensic issues. From the time when number of organochlorine pesticides has been banned, the cases of poisoning involving these compounds has been declined. However, cases of accidental deaths are still reported due to surreptitious use of pesticides. Today, many household insecticides consist of carbamates and pyrethroids, and hence poisoning involving them are on the rise, particularly among us children. Poisoning due to other pesticides is comparatively rare, except among individuals who are occupationally exposed. Owing to easy availability, pesticides such as organophosphates and carbamates have always been extremely popular in India for the purpose of committing suicide. In current scenario, aluminium phosphide has initiated to find increasing favor and has in fact edged out the other insecticide from the top spot in some states. Homicide poisoning comprising pesticides has always been unusual owing to disagreeable odor, taste, which most of these substances possess. Significant exceptions include thallium and arsenal compounds. However, cases have been reported even with other pesticides. Pesticides poisoning is menace in India subcontinent and is a reason behind most of the cases reported of accidental, homicidal or suicide in the forensic laboratories. The rate of their abuse is high because of their readily and easily availability in the market. They are also present in most of the insects and mosquito repellents which are over the country articles. Detection of the pesticides is not easy because of the wide diversity and huge amount of examples available presently in India. Example, according to Insecticide Act 1968, there are 186 chemical pesticides registered for use in India under Section 9(3) as on 7th March 2005 and 31 formulations banned and 7 as restricted to be used in India only. India is principally a rural-oriented country which consists more graphical rural area in comparison to the urban areas, and unfortunately the literacy rate is in very poor conditions. So it could be understood about pesticide poisoning by an example, as the agriculture needs pesticides for the purpose of good yield of crop. By killing pest, the farmer comes in the contact of that pesticide, which is of course accidentally happens, could result the death of that persons. Classification of pesticides. Pesticides can be categorized as per their chemical structure. Pesticides with analogous structures have alike features and generally have a same method of actions. Most pesticides are active ingredients, either inorganic or organic. From a technical interpretation, inorganic pesticides do not comprise carbon and are generally extracted from minerals or extracted from the earth. Examples of inorganic pesticides comprise copper sulfate, ferrous sulfate, copper and sulfur. On the other hand, organic pesticides include carbon in their chemical structure. Most organic compounds are made from several combinations, but a few are extracted from plant material and are known as botanicals. Example of organic pesticides include captan, pyrethrin and glyphosate. Organochlorine pesticides. The chlorinated hydrocarbon insecticides were introduced in the 1940s and 1950s and comprise convergent insecticides such as DDT, methoxychlor, chlordane, heptachlor, aldrin, dieldrin, andrin, toxaphene, mirax and lindane. Though DDT was manufactured in 1874, its insecticidal properties were not noted until 1939 when Dr. Paul Muller, a Swiss chemist, discovered its efficiency as an insecticide and was given a Nobel Prize for the efforts. During the World War II, the United States used large amount of DDT to control vector-borne disease like typhus and malaria, to which US troops were uncovered. After the war, DDT use turned out to be widespread in agriculture, public health and households. Its persistence, originally called as a desirable attribute, later turned into the basis for public anxiety and ultimately led to the prohibition of DDT and other chlorinated insecticides. These combinations are available as dusting powder, wettable powders, emulsions, granules and solutions. There are 4 distinct categories of these pesticides: DDT and analogs, DDT dichlorodiphenyl trichloroethane, methoxychlor, number 2 benzene hexachlor group, benzene hexachloride, BHC, gamma hexachlorocyclohexane, lindane. Number 3 cyclodienes and related compounds, aldrin, dieldrin, endosulfan, thiodane, andric, isobenzene, chlordane, chlordecone, capone, heptachlor, mirax, D-chlorane. Number 4 toxaphene and related compounds, toxaphene. Fatal dose: dieldrin is placed in extremely toxic category, LD50 1 to 50 mg per kilogram, while DDT, endosulfan and lindane are considered highly toxic. LD50 is 51 to 500 mg per kilogram. Organophosphorus pesticides, also known as organophosphates, are among the most widely used insecticides in India as well as in the whole world. Organophosphates are phosphoric acids, esters or thiophosphoric acid esters, and are among the most widely used pesticides. During the decades of 1930 to 40, Gerhard Seder and his co-workers realized the insecticidal properties of these compounds, and by the end of the World War II, they were successful to make many of the insecticidal organophosphates used at present. Chlordane, a cyclodiene insecticide, was used extensively as termiticides in 1980s but was removed from the market due to calculable residues level allegedly causing health problems. These compounds are available as dust, granules or liquids. Some products needs to be diluted with water before use, and some are burnt to make smoke that kill insects. Parathion, fatal dose, extremely toxic, LD50, 1 to 50 mg per kilogram, to highly toxic, LD50, 51 to 500 mg per kilogram. Chlorphenvenophos, chlorpyrifos, dimetone, dizinone, dichlorovis, dimethoate, disulfotone, adiphenphos, ethione, phenitrophthione, phensulfothione, phanthione, phonophos, formothione, methylparathione, mavinphos, monocrotophos, oxydametone, methyl phanthoate, phorate, phosphomidone, quinolphas, TEPP and thiometone. Moderately toxic LD50, 501 to 5000 mg per kilogram, to slightly toxic LD50 greater than 5000 mg per kilogram. Abate, acephate, coumaphos, crufomate, femfer, glyphosate, malathion, phanthoate, primifos, methyl, ronel, tempaphos, trizophos and trichlorphon. Fatal period. In fatal doses, symptoms starts within half an hour and death occurs within 3 hours. In non-fatal cases, effect lasts for 36 hours and fade off in 48 to 72 hours to 3 weeks. Carbamate pesticides. Carbamates are as popular as organophosphate in their role as insecticides and fungicides and share a number of resemblances. Carbamates are the group of insecticides which are derived from carbamic acid, within the bracket monoamide of carbon dioxide, aryl or alkyl, ester derivatives of carbamic acids. Besides them, as additional group of carbamates, insecticide also exist which are derivatives of aliphatic oximes rather than esters resembling aldehydes or ketones, collectively known as methyl carbyl oximes. Carbaryl, fatal dose, extremely toxic, LD50, 1 to 50 mg per kilogram, to highly toxic, LD50, 51 to 500 mg per kilogram, aminocarb, bendiocarb, benfercarb, carbaryl, carbofuran, dimetane, dimethylane, dioxocarb, formetinate, methiocarb, methonyl, oxamel, propoxer. Moderate toxic, LD50, 501 to 5000 mg per kilogram, to slightly toxic, LD50 greater than 5000 mg per kilogram, LD carb, bufencarb, isoprocarb, MPMC, MTMC, pyrimicarb. Pyrethroid pesticides. Pyrethrin are active extracts of the chrysanthemum plant. Chrysanthemum cinereofolium and includes pyrethrum and pyperonel butoxide. They are esters of pyrethric and chrysanthemic acids formed by the keto alcohol pyrethronolone. Cinereolone and jasmolonone, pyrethrum 1 and pyrethrum 2 are two of the most insecticidally potent pyrethric and chrysanthemic esters. Pyrethroids are synthetic analogous and number over 1000 varieties which are used as insecticide to incapacitate or knock out insects. Most mammals are resistant since they can rapidly metabolize and detoxify these agents. These compounds are used as household insects, repellents and insecticides. They are sold as liquid, spray, dust, powders, mats and coils. They are also used to prevent pest infestations in granaries and in agriculture as pesticides. Pyrethrum extract is effective for treating pediculosis of the head, body and pubic area. Fatal dose. Pyrethrum has a LD50 of over 1 gram per kilogram. However, the minimum lethal dose of pyrethrum is not clearly established. Though it is probably in the range of 10 to 100 grams, most cases of toxicity are actually the result of allergic reactions. Mode of action of pesticides. Organochlorinates. All the organochlorines can be absorbed transdermally, orally and by inhalations. Gastrointestinal absorptions of these agents is generally efficient, particularly in presence of absorbable lipids, animals or vegetables fat. DDT is the least well absorbed transdermally, while dieldrin is very well absorbed. Many of these compounds are metabolized slowly and persist in tissues, especially fat. For prolonged period, high residue level from organochlorine insecticides poisonings are found in adipose tissues. However, unlike other organochlorine pesticides, methoxychlore does not substantially accumulate in fatty tissues of human. Organophosphorus. Organophosphates are powerful inhibitors of acetylcholinesterase, which is responsible for hydrolyzing acetylcholine to choline and acetic acid after its release and completion of functions. Within the bracket, that is propagation of action potential. As a result, there is build-up of acetylcholine with continued stimulation of local receptors and ultimately paralysis of nerves or muscles. Although acetylcholinesterase molecule at the active sites and phosphorylate the serine moiety, when this occurs, the consequential conjugate is infinitely more stable than the acetylcholine. Acetylcholinesterase conjugate, although endogenous hydrolysis does occur. Depending on the amount of stability and charge distribution, the time to hydrolysis is increased. Phosphorylated enzymes degrade very slowly over days to weeks, making the acetylcholinesterase essentially inactive. Once the acetylcholinesterase is phosphorylated over the next 24 to 48 hours, an alkyl group is eventually lost from the conjugate. Further exacerbating the situation, as this occurs, the enzyme can longer spontaneously hydrolyze and becomes permanently inactivated. Apart from acetylcholinesterase, organophosphates exert powerful inhibitory actions over other carboxylic acids, hydrolases such as chymotrypsin, butyrylcholinesterase, within the brackets pseudocholinesterase, plasma and hepatic carboxyl esterase, peroxygenases and other non-specific proteases. Carbamates. Like the organophosphates insecticide, the mode of actions of the carbamate is acetylcholinesterase inhibitions, with the important difference that the inhibition is more rapidly in reverse than with organophosphate compounds. This is a reversible type of binding and hence symptoms are less severe and of shorter durations. As a result, both morbidity and mortality are limited, which compared to organophosphate poisoning. Also, since carbamates do not penetrate the CNS to the same extent as organophosphate, CNS toxicity is likewise much less. With respect to all other clinical manifestations, there is general similarity between carbamates and organophosphates. Carbamates are rapidly metabolized, they are rapidly hydrolyzed by liver enzymes to methyl carbamic acid and a variety of low toxicity phenolic substance. These metabolites may sometimes be measured in urine as long as 2 to 3 days after significant pesticide absorption. Pyrethroids, low toxicity mammals is probably due to rapid metabolic breakdown in the liver. Pyrethrum is broken down mainly by oxidation of the isobutynyl side chain of the acid moiety and of the unsaturated side chain of the alcohol. Moiety with ester hydrolysis playing a role. Pyrethrin affect nerve membranes by modifying the sodium and potassium channels, resulting in depolarizations of the membranes. Formulations of these insecticides frequently contains the insecticide synergist pypironyl butoxide, which act to increase the efficacy of the insecticide by inhibiting the cytochrome P450 enzyme responsible for the breakdown of the insecticide. Toxicokinetics of pesticides. Organochlorine. Excretion of organochlorine compound does not follow first order kinetics. As body stores get lower, the half-life for the remaining store increases dramatically. This is probably due to complex lipoprotein binding, wherein different bound forms exhibit different dissociation characteristics. Organophosphates can be absorbed by any route, including transdermal, transconjunctival inhalations across the GI and GU mucosa and through direct injections. Appearances usually begin with a few minutes to few hours, but may be delayed up to 12 hours or more in the cases of certain compounds. Example, phanthiones, parathiones. Carbamates. Carbamates, being highly volatile, have various mode of absorption in case of occupational poisoning, but the most likely is through skin, that is dermal toxicity. The lipophility of this class of agent and presence or organic solvents and emulsifiers ensure a rapid dermal penetration and absorption into the systemic circulations. Carbamates are readily absorbed in the gastrointestinal tract, and the efficacy of absorption is guided by the vehicle in which it is administered. The excretion of water, soluble byproduct of detoxifications, occurs relatively rapid through the urine and or feces in most vertebrate species. Glucuronide and sulfate derivatives of the aryl substituents are the major product found in the urine. A small amount of the parent carbamates may be excreted in the urine. Pyrethroids. Structurally, pyrethroids are of two types. Type 1, pyrethroids do not contain a cyano group, example permethrin. Type 2, pyrethroids contain a cyano group, example deltamethrin, cypermethrin, phenpropythrin, fenvalerates. Like DDT, pyrethroids extend the inactivation of the sodium channel by binding to it the open state. Type 2 agents are more potent in this regard and also act by inhibiting GABA-mediated inhibitory chloride channels. Introduction to herbicides, within the bracket weedicides. These are compounds which kill weeds. They are also known as weedicides. The main example of herbicides are acrolein, delafon, paraquat, diquat, glyphosate, atrazine, propagine, simazine, nitrofen, trichloroacetic acid and chlorophenoxy compound. Some important weedicides are discussed as under. Paraquat and diquat. Paraquat and diquat are widely used herbicides which belong to bipyridyl group. Paraquat is 1,1-dimethyl-4,4-bipyridyl lumidichloride and was first synthesized in 1882 but began to be used as an herbicide only since 1960. It is available either in granular form 20 to 80 grams per kilogram or as water soluble concentrate, which is in an odorless brown liquid within the bracket 100 to 200 grams per liter. The granular form is available as colorless crystals within the bracket dichloride salt or a yellow solid bis-methyl sulfate salt. In India, most of the concentrate of paraquat are available as 10 to 20% solutions, and therefore 10 ml of 20% solutions can contain about 2 grams of paraquat. Common brand names include Vidol, Gramoxone and Uniquat. Diquat is 1,1-ethylene 2-dipyridinium dibromide and is less commonly used than paraquat. It has the same indications and mode of actions as paraquat, but product much less severe pulmonary lesions. Paraquat. Fatal dose. The fatal dose of paraquat and diquat is approximately 4 mg per kilogram. Fatal period. Usually the fatal period is 3 to 5 days, but may vary with the intervening factors. Mode of actions. Paraquat is rapidly acting herbicides. It kills the tissues of green plants by contact action with the foliage and by some amount of translocations to the xylem. Toxicokinetics. Absorption through inhalation, skin contact or eye contact is minimal. Through prolonged contact can be hazardous. On ingestion, paraquat solution is much more rapidly absorbed than the granular form. After absorption, it tends to accumulate in the lungs and kidney. Paraquat has a large volume of distribution within the bracket 1.2 to 1.6 liter per kilogram. More than 90% of an absorbed dose is excreted by the kidney as the parent compound within 12 to 24 hours. Paraquat is distributed into all organs. Highest concentration are found in kidney and lungs. Paraquat also accumulate in muscle tissues, which may represent a reservoir, explaining prolonged detection of plasma or urine paraquat weeks or months following injections. Chlorophenoxy compound. Chlorophenoxyacetate herbicides includes the following: MCPA within the bracket 4-chloro-2-methyl-phenoxyacetic acid, MCPP within the bracket 2-methyl-4-chlorophenoxypropionic acid, DCPP within the bracket 2,4-dichlorophenoxypropionic acid, 2,4-D within the bracket 2,4-dichlorophenoxyacetic acid, 2,4,5-T within the bracket 2,4,5-trichlorophenoxyacetic acid. These herbicides are used to kill broad-leaved weeds in cereal crops, grasslands, parks and gardens, and weeds in ponds, lakes and irrigation canals. Common brands of chlorophenoxy compounds are 2,4-D, phenoxone, weedness. Mode of action: rapid and complete absorption of chlorophenoxy compound from the GI tract has been reported. Dermal absorption is limited. Chief organ of depositions are kidney, liver, central and peripheral nervous system, and the gastrointestinal tract. Toxicokinetics. They are highly protein bound. Phenoxy acid ester salts are primarily metabolized by acid hydrolysis. A minor amount is conjugated. They are primarily eliminated unchanged 90% within the bracket by the kidney via the renal organic anion secretory system. Glyphosate and aminophosphonate is used as an herbicide. It is an odorless, colorless to white crystalline powder and is weakly acidic. Glyphosate herbicides are commonly applied in spray form and primarily formulated as either a water-soluble liquid or concentrate solution, or a solution made with a water-soluble powder and other ingredients. Fatal dose: ingestion of greater than 200 ml is likely to produce severe toxicity. Mode of action: the surfactants present in commercial solutions, polyoxyethylene amine and anionic surfactants may be responsible for many of the toxic effects of glyphosate. Surfactants alone may cause circulatory failure, respiratory failure, seizures, generalized edema and gastric erosions. Glyphosate appears to undergo minimal metabolism. Results from animal studies indicate that essentially no toxic metabolites are produced and nearly 100% of the body burden is parent compound. Summary: acute pesticides poisoning is a serious global problem, accounting for an estimated 3 million cases of severe poisoning worldwide each year, with approximately 220,000 deaths. More than 90% of these cases are reported from developing countries such as India. Apart from the pesticides are a major source of concern as water and soil pollutants. Because of stability and persistence, the most hazardous pesticides are the organochlorine compounds such as DDT, aldrin, dieldrin and chlordin. Persistent pesticides can accumulate in food chain. This bioaccumulations has been well documented with the pesticide DDT, which is now banned in many parts of the world. In contrast to the persistent insecticide, the organophosphorus pesticides such as malathion and the carbamates such as carbaryl are short-lived and generally persist for only a few weeks to a few months. Thus, these compounds do not usually present as serious a problem as the earlier insecticides.